Hey everyone, welcome back to the lab. In this video, we're going to be talking about building software monoliths for scale. So why am I making this video? Well, I think the problem is that conventional wisdom, textbooks, conference talks, university professors for years have been saying that microservices are better than monoliths. And we see this in the industry all the time. All sorts of companies are trying to go to microservices. And the problem is that I think this is wrong like 95% of the time. And so the way I'm trying to solve this is, in this video, I'm going to give 3 reasons why monoliths do scale and some explanations of why they often scale better than microservices do. So my belief is that monoliths are simple scalable systems, and on this channel, I talk about simple scalable systems a lot, which are basically strategies that are good for 95% of use cases. They're not A+ in most, but they are a solid B+ in basically everything. And so we're talking about monoliths here. All right, so what we're going to talk about is first the 3 reasons. So we're going to go simplicity, speed, and scalability, and then I'm going to leave you with some takeaways. My answer to the question, should you use monoliths or microservices? And then finally, a bonus of what system architecture do I use in my own projects and do I recommend? Okay, so let's start off with simplicity. So the truth is that monoliths are simple and easy to understand. It's harder to get much simpler than this. On the left, we've just got a monolith that's just one server, and then we just look at microservices and wow, there's like a lot more servers, like it's just more complex. And when I think of like some specific reasons why I think monoliths are just really a lot simpler than microservices, I think there's 3 big ones that often get overlooked. And so the first one is that all code is in one code base. And this might seem dumb, but I think when we compare it with microservices, it's pretty clear the complexity that's added. So the first one is for code sharing. Like if we want to call some function that exists in our code base, if we're in a monolith, all we got to do is call it. And, we already have all the types for that call because it's in the code base. We literally have access to it. So we're going to be using the correct, type and form and stuff like that. Now, if we look at the microservices side of like, what does that mean to do the same thing? Well, you kind of have to figure out a way to actually share this code if it lives in another service. So a lot of times what people will do is they'll try to package up their types or build an SDK and send it out to the other services to use. And that's okay, but that's a lot of complexity. Now you gotta, make sure you're out the right version of package. Someone actually has to publish it, do things like that. And a lot of teams, they don't want to deal with that. So instead what ends up happening is people start copying and pasting types from one service to another, or even just the actual functionality. And we can see how that doesn't really stay correct and updated if one decides to change and the other one doesn't. And so what I actually see a lot of teams doing is going further and just not typing it at all. They just kind of get whatever the shape of the request is, and they'll just send it over the network. And now we've lost all type safety across here because we're now doing some sort of RESTful thing. So in this case, just having all the code base in one repo and then running on the same server, then it just makes it a lot simpler. The second part is when we get to deployments. So when we think of, a monolith, the deployment's pretty simple. We're just like, got one code base, we're going to ship it, it's a blob of code, and we're going to like put it on a server somewhere and configure it. And that's it. But when we get to microservices, now we've got to redo that deployment process and whatever that logic is, however many times we have the microservice. And not only that, we've got to deal with versioning of these microservices. Like hopefully they're not dependent on each other to be some sort of version to work, but in my experience, a lot of these microservices are dependent on each other. And we've got to deal with, well, what if one rolls back and the other one doesn't? What if, one has some servers that are just running a different piece of code? It's all these same problems that we have with deployments with one code base, but now we've just got it a bunch more because we're dealing with so many different kinds of code bases and different kinds of ways that it can deploy. And the last one, which is really a product of all of these, is that when we have a monolith, just one blob, it is much easier to test end to end because we just got to get that one blob spun up and then we can just hit it and it just kind of acts like, the way it should act. If we don't have this, and we're now dealing with several different code bases, we now have to do all of that stuff together, which just adds complexity. And in my experience, the harder or more complex it is to spin up like a dev environment or a test environment, the less likely it is that it's going to work the same way that prod does. And the problem with that is that if we can't test a mirror image of prod, something that works exactly like the production code base works, we are now no longer testing what actually happens, and we're gonna let a lot more code defects in. And I have been consistently surprised in my career how often organizations cannot spin up a mirror image of prod, and so we end up just shipping code thinking it works and it just doesn't. So there's just a few reasons I think monoliths are much simpler than microservices, but we'll talk about this as we go on. So that was a lot of me just like talking in words, but I kind of want to show this in pictures too. So here in the simplest case, we just have a monolith and we just think of overhead times 1, right? So on the left, we've got this web request coming in. It just kind of comes in, it hits a machine, and like presumably it returns. And then we have this other path here, which is like, how does code get on this machine? And just really simplistic, you got your code repo. We've got some sort of like pipeline that does testing or whatever and then actually deploys. And that's how it gets there. Now, it's basically as simple as you can get. Now, the problem with microservices is that, we've got all this same thing, but we just have to do it a bunch more times. And so, yeah, we have this request coming in and, we might have an API gateway to like tell it which, different services it even needs to talk to. Sometimes there's like a central app server that it hits first, and then that works as like the delegator to hit all these services. And then we think of all of these extra code repos we have, and like someone has to keep all of these up to date, and now we've got all these different pipelines, and someone now needs to keep all the pipelines up to date. Is there a central team that does that? Is it like every team does it themselves? Well, how do we keep it so that it runs on the same infrastructure? How do we make sure that each of these is up to date to hit whatever our core services are, like auth or something like that? And so there's just like a lot more complexity here. And when we think about that, it's kind of looks like it's overhead times n. So maybe like a linear curve. But when you actually think about this, if we kind of think of it more of in like a graph standpoint, where each of these services is a node, the problem is we also actually have to deal with like the interconnectivity of each of these nodes to the other nodes, because presumably there's services that, we can reuse. And now we start getting to, it's not just the nodes that matter, but maybe it's the edges that matter. And then we start getting into like a land of maybe like n over 2 or something, or sorry, n squared. And that just becomes a lot more complex. And I think people often forget about this kind of complexity. And so all this is to say that for microservices to make sense, I really think you just need to make sure that the benefits outweigh the complexity. And there's a lot of complexity in microservices that I think are non-obvious and people often forget. Okay, so that's simplicity, the biggest one. And now I want to go to speed. So I think for most organizations, most companies, speed is actually the biggest problem. And the reason is because this ties directly into money, right? The speed at which you can ship software is directly going to be proportional to the time to market for whatever feature it is, whatever kind of business tactic you're trying to make. And so time itself to market has a lot of costs. It's the cost of like actually paying your employees, of paying for the server so that the site's up, anything like that. And then opportunity costs of your competitors aren't going to be sitting still while things are happening in the world. They're also going to be trying to tackle these opportunities, and so that's lost business for you. And then if we think of smaller orgs, which is probably a lot of people who are here building things, that time to market is even more crucial because a lot of these don't have enough customers or any customers to actually have a sustainable business. And so they're really iterating to get product market fit. And so all this time that's spent building something that's not actually the biggest problem for your org, that's just taking away from the survivability of your actual business. And so my posit here is that simplicity actually leads to easier to understand code, which means that code iterations themselves are faster because it's easier to make changes. And then when we make changes, there's typically less bugs because that code was easier to understand in the first place. And so not only are we shipping faster, but we're also having to revert less because there's less bugs getting shipped. And so if we take this in context with the idea that monoliths are simple, we also come out with the idea that monoliths are fast, which for most orgs, for most companies, is the most important thing. And again, with the drawings, just an example. So let's say you did do all this work to design and architect and build and ship, your really cool microservices. That's great. It can probably scale to like so many customers. But the problem is if you have less than 10 or 100,000 customers, this like probably didn't matter at all. And that's like the low end. You could probably scale much higher with monoliths. And so this whole microservices thing that you just shipped just like didn't make sense. You're just burning money. Okay, last but not least, we're going on to scalability. So the conventional wisdom for a long time has just been that monoliths don't scale. You just have the server here and you're going to send some requests and they're just going to fail. They're going to time out. Like, your users are going to be mad. It's going to fall over. It's just going to be on fire. And the truth is, if you build your software like this on a single server that's just like, sitting in your closet and, connected via your home Wi-Fi, like, yeah, it's probably going to crash and burn. It's going to be slow. It's not going to be great for your users. It's not going to scale with your business. But the thing is, like, we don't build software like this. We've got the cloud. It's really easy to spin up a ton of different servers at a moment's notice, and also to make those servers really, really big. And so this gives us a lot of leverage, a lot of ability to scale these things beyond just the servers you can kind of fit in your closet. And the cool thing is that, as time goes on, it seems like these computers are getting much cheaper and much easier to scale out. And so this just becomes more and more powerful as time goes on. And if you don't believe me, like, we have real world examples of these monoliths really reaching high scale. So Stack Overflow, developers' favorite website, is running on 9 servers right now. This is just monolithic application on 9 servers. So they've got 6,000 requests per second, 2 billion per month. They're running 175 different sites. They got some sort of multi-tenant .NET app running on 9 servers. And the truth is, most people watching this, most people building companies, most people building software are never going to have to handle traffic as high as this. And so if it works for them, then it will probably work for your use case as well. And I think as we talk about scalability, everyone's saying microservices are just like always faster and more scalable, but we forget there's like all these hidden costs with microservices, and they're really, really important at scale. And so one of these is that microservices incur network costs. So when you look at a monolith, we'll just assume this is one server, and each of these little packages is like just some code that you're trying to call in there. When we're making these calls, it's all just in process. It's in the machine, and like, yeah, there's some overhead. We gotta wait for I/O. We got some contention in here, sure, but it's all the same machine, and relatively speaking, kind of fast. If we just blindly break into microservices all these packages that we have, not only are we doing the same work compute-wise, because at the end of the day, you have to do the same work to get the same thing done. But now we're adding a bunch of different network requests in between, and that's like really high. That costs a lot. And now for some of these, it might make sense. Like, if your thing really takes a lot of compute, it might make sense to break it out and scale that thing up by itself. But for a lot of these things, when we're just kind of breaking blindly by domain, they weren't doing that much compute processing. Like, most stuff just kind of like does some basic checks and then goes and hits like a database for some I/O or something like that. And so now what you're doing is you're just adding additional network costs on top of a simple wrapper, and you're just making everything that much more expensive. And so when we think at it from, scalability, microservices starts to make sense when the compute wins is greater than the network costs that we are incurring. But the thing is that, like, a lot of times the compute is just like not going to be greater than the network cost. Like, most of the app, again, is just kind of checking random things on some object and then, doing some stuff. That's like pretty fast. There's only going to be a few places and bottlenecks where we're really doing compute heavy stuff. And so in those cases, it makes sense to break out. But if we start looking at the shape of this, it's almost like it's mostly monolith and just a little bit of microservice. And this is exactly the direction that like Meta and Instagram took. They're mostly monoliths. They have a hybrid architecture, but it's almost all monoliths, and they're just breaking out some specialized stuff. So they're running hundreds of thousands of app monoliths. Some of it's the PHP hack, which is running like Facebook, and then some of it's Django, which is Instagram's version of Python. But it's the same code, just 100,000 times. And then some things don't make sense to be in the monolith. Like, when you think of things that require special hardware or that are like really compute intensive, like video processing or like ML workloads, things like that, they make sense to be on and microservices broken out of that monolith because they require such specialized, requirements. And you can check me, this is all online, but I also worked there for 3 years, so, this is how it works. And so I want you to take away from this that monoliths scale, and they scale enough, and they scale plenty 95% of the time. And so now we come to that question, like, monoliths or microservices? And the answer should be pretty clear. I think monoliths for most. They just are simpler. They allow your org to move a lot faster. And then when we talk about the scalability problems, the reason that everyone's saying microservices to start with, those problems just almost never exist, and when they do, it's pretty simple to solve them. And so for 95% of you, I really think monoliths make sense. They are the simple scalable system for how to build your system architecture. Now there's always edge cases, and so I will say that microservices work sometimes only when the benefits are greater than the costs. And I would say that you will know when microservices make sense because the pain of staying monoliths, the pain of not breaking these things out is going to be so much higher that it's almost going to be impossible to do anything without doing it. But again, this probably won't be most. This is probably going to be when you're in the millions of customers and probably high hundreds to thousands of engineers. That's probably when you're going to be feeling this. So what is my go-to software architecture? What do I actually use in my projects? And basically I use service-based monoliths, which is that kind of hybrid approach where most everything is in a monolith, and then we can break out specialized workflows into their own things to scale where we're having scalability problems. Now I take it a little bit more coarse-grained than that. I like to have monoliths for every very large domain. So for instance, I usually start with a web monolith and an app monolith, which is like my API and doing any kind of compute-intensive stuff. And then from there, I can break out if I find a use case that's obviously different or specialized. So if you want to learn more about how I build projects, including more details about this kind of system architecture, what kind of technologies I use, how do I deploy them, what hosting do I use, you can check out this video on CloudSeed, which is the F# SvelteKit boilerplate I use for every project. And that's it. Let me know if you have any questions about these system architectures, if you disagree about my takes on monoliths and microservices. And as always, this is where you can find me to send me that feedback. So I think that's it. Thanks for watching, and I'll see you in the next one.